Good morning, everyone. Day 2. Oh, no, it's day 3, week 2. How are we? Grandson put a crown on me, so I thought it looked pretty cool. But let me take it off so it doesn't look weird. Yeah, day 3 should be pretty doable. It's just quizzes. I'm going to screenshot some of the problems you'll see and how it is that you would find the actual distance for those measurements. So stay tuned. Coming soon. Alrighty, day 3, we're still finding missing sides of right triangles. They also call it distance. So you're still wondering how can we do that on this brand new 2020 Wednesday activity. So here's what you'll see. You'll see questions such as which letter matches the coordinate for -6. You do have to remember that this is the x coordinate and it goes left and right. This is the left and this is the right. This is the y coordinate. It goes up and down. So this is up and this is down. So right now, this is asking us to go 4 to the right, 4 to the right, and 6 down, and 6 all the way down. So we just got to z. So z is the coordinate that is on those coordinates. And that's how you'll tackle some of these questions. And another question looks like, but I'm hoping you remember about the coordinate plane. Here's what distance looks like in geometry. If you go from one end to the circle to the other end, then you're looking for a distance that has to do with the x-axis, which means if you go from -8 to -4, think about how many spaces you travel. You don't have to use the Pythagorean theorem. So if we go back 1, 2, 3, 4 spaces, so the diameter is the whole thing. Half of it, they call it the radius. So some language that is coming up, it's better to be proactive. So the diameter is 4. That was my grandson. He's on the background. She's doing cool stuff. Moving along with the next situation. Now we're getting to distance. Now we're getting to using the Pythagorean theorem. If you feel comfortable with the distance formula, then go ahead and use that. That's perfectly okay. So I see that the distance from here to here, it's a total of 2. Because from 3 down to 1, it's a total of 2 spaces. So 2 squared. So a squared will be 2. B squared goes from -2. I'm going to count all the way to 4. So from -2 to +4 is 6 spaces. 6 squared equals c squared. That should give us a measurement of c squared. So I'm continuing with the same process as we did yesterday. A squared is 4. B squared is 36. And that will make c squared, which means c has to be 40. C squared has to be 40, so we still got to do the inverse of square, which is square rooting. So the value of c is actually 6.2, 6.3, around there. And that's how you can use the Pythagorean theorem to find distance. Again, if you feel like you can use the distance formula, go ahead and do that. That's also very, very okay. Last but not least, we have another right triangle, so we're going to apply the Pythagorean theorem again, because that only works for right triangles. So that'll be 49, because 7 times 7 is 49. That's A, by the way. Notice how we have B here. So B squared is going to be B squared. We don't know what it is. And then C squared is 25 times 25, which is 625. So we can't really add them, so we do the inverse. So -49 and -49. So we're trying to find B in this case, not C. C is always across from the right angle. So B squared has to be whatever that it's equal to. So, and then 576. So the square root of 576 should be a total of 24, because 24 times 24 is 576. Notice how the square is gone because we square rooted both sides. So we can say x equals 24. It should make sense. It's a mid-size side. It's almost 25, but it's not the same. So that's all the notes for the day. I don't have anything else for you. Enjoy the task. Continue tackling the task. Have a great day. We'll see you before we depart, we have a message from Mason Jordan Chapa. Go ahead, sir.
Do you wait?